So you start out the exact same way. I got the big 5. Break into I hat and J hat. And again, you don't have to have J hat up. Some people prefer to have acceleration and the final displacement positive, so you can make non-positive, but I dared make J hat upwards. All right, so what do we know?
The displacement in the J hat direction is 15 meters.
Is what?
Negative 15 meters.
Okay.
Separation negative 9.8 on J hat,
Yep. Units?
meters per second. Squared.
The acceleration is 0 in the I hat direction, 0 meters per second squared.
And just a side note on that sort of extension of my answer to Kelly, the first attempt. When we get into force diagrams and basically analyzing the forces, this is primarily just math, the more physicsy. We're going to figure out the direction of acceleration and then choose our I hat, J hat based upon that, so that we have one component in the direction of acceleration and the other component perpendicular to that, so that the math becomes basically 25% as hard. 75% easier, however you want to view it.
The initial velocity in the J hat direction would be 30 meters per second sine 37 degrees.
Okay, so this gets into the initial velocity. Because it is not all horizontal, neither of these are 30 meters per second. Some of it's up, some of it's to the right. So we have to do some trig. So I have a vector that represents 30 meters per second. There are components. There's a horizontal and vertical component. That's a 37-degree angle. The opposite is associated with sine. So my opposite side here is going to be the hypotenuse, 30 meters per second, times the sine of 37 degrees. Cosine's associated with the adjacent, 30 meters per second, times the cosine of 37 degrees. So I'm going to do an aside here for those whose trig is still in the elementary stage. If I have a triangle here, that's theta, and call that A, B, and C. The cosine of the angle is the adjacent over the hypotenuse. The sine of the angle is the opposite over the hypotenuse. And the tangent of the angle is the opposite of the adjacent. If I'm solving for B, the length of this side, and I know the hypotenuse, I multiply both sides by C, by the hypotenuse length, and so I'd end up with B is equal to the hypotenuse times the cosine of the angle. From this one, multiply both sides by C, I end up with the opposite side, A, is equal to the hypotenuse times the sine of the angle. So that's where this is. And 30 times the sine of 37 degrees is about 18. And this one would be about 24. I think it's slightly higher than 18 and slightly less than 24.
18.05.
Okay. I chose 37 degrees so that it would work out close to 18. If you wish to take the extra decimal points, go for it. So my horizontal component is 24 meters per second. My vertical 18 meters per second. They are both positive because I chose my positive direction so that it is initially going in the positive direction in I hat and j hat. This is what I'm trying to find. And this is now the same setup as we had last time, we just have fewer zeros. Guess we have one fewer zero. So, once again, we find ourselves trying to solve for time. Which equation?
The first one?
Yep. Yet again. So j hat, we have negative 50 equals 18 times time minus 4.9 t squared. And the 4.9 comes from 1/2 of 9.8. It is a quadratic equation. Potentially, you could factor it, complete the square, use quadratic formula, which are probably the simplest. So 4.9t squared minus 18t minus 50 equals 0. T equals 18 plus or minus the square root of 18 squared minus 4 times 4.9 times negative 50 divided by 2 times 4.9. There are two answers. What are both of them? Robert, do you have a question? You need to look on your
I'm
read.
just trying to figure.
Okay. I do expect, for the two answers, I expect one to be positive, one to be negative. I expect the magnitude of the positive one, or the absolute value of the positive one, to be greater than the absolute value of the negative one. So one question is, why would I expect this? But as we'll eventually get the numbers. Our discriminant will be positive because I'm subtracting a negative number. So I know we're not going to get an imaginary answer.
One
106.47. That seems awfully large. Did you divide by that?
Yeah. That's what I was thinking too. I don't know why.
3.71.
Would you have?
3.71.
That makes more sense.
Might be.
Or even though only one of the answers fits the problem, mathematically there are two answers that do have some meaning.
I think it was more.
What? 0.2? Rick, what?
I got it. Negative 1.8 and 5.5.
Negative 1.8
And 5.5.
at 5.5?
That's what I had.
The negative 1.8 and the 5.5? All right, seem to have a groundswell there. All right. All right, so we have our two answers there. What is the correct answer for this problem?
5.5.
What is the meaning of the negative 1.8?
If you were behind and below, like where you threw it.
Yeah. So what we're working on here is mathematically, we're looking at a parabola. So mathematically, the math says we're looking at a parabola like this, and it's going to cross my time axis here and here. This is actually when the problem starts, with the object going in that direction. So that negative 1.8 seconds, and this would be the 5.5 seconds. This would be if I shot it in the other direction at 30 meters per second. So if I shot it in that direction at 30 meters per second, how long would it take to get down to here? It would take 1.8 seconds. Since we're going in the other direction though, it's sort of back in time. I know since it was shot upwards that the peak is going to be somewhere, well, it's going to be to the right of it. The object's going to peak. And so therefore I know that the negative answer has got to be smaller in magnitude than the positive answer. If that 37 degrees had been downwards, then I would expect the positive answer to be smaller than the negative answer, magnitude-wise. Questions to hear? Okay. No, we actually haven't finished the problem yet. So we now have time is 5.5 seconds. We now solve for R. What is the equation?
The same one.
And so now I have R is equal to 24t plus 0. 24 times 5.5. Which is something spectacular.
132.
Say it again?
132. Yeah, 132. Millimeters per second.
What did we find?
The R,
Which is
just meters.
meters. Which I heard over there. All right, 132 meters is the final answer.
And which formula did he use again?
Pardon?
Which formula did he use again?
The first one, both times. All right, let's adjust it. What's the final velocity? You know this now. This is 132 meters. Now I'm asking, what is the final velocity? Oh, what formula would we use?
Initial plus acceleration times time.
All right. So Kelly suggested we use this one right here. So let's do I hat first. So my final velocity in the I hat direction is equal to 24 plus 0 times 5.5. I got this one. All right. Again, the horizontal component doesn't change. So this is 24 meters per second. Vertically. So a V final vertically is equal to 18 plus negative 9.8 times 5.5.
Negative 35.9.
What is it?
Negative 35.9, I think.
Yeah, that's what I got.
That's one in the wrong direction. All right, negative 35.9.
Meters a second.
Okay. So, what's the answer? The question is, what's the final velocity? So, what is the final velocity?
24,
Pardon?
maybe 24.
Yep. This is a question that stumps people on tests too. We've done all the hard work. But people just sort of stop at that point and go, well, I guess I'm done. No, we're not done yet. We haven't actually answered the question.
Negative 11.9.
How'd you get that?
I added that's, never mind.
If you did that on a test, you might see either that or that. Not how math works or not how vectors add. I write it enough that I've come up with the abbreviations. So not how vectors add. Luis, do you have an answer?
No, not really. But
Okay.
since for the initial velocity we had to do sine and cosine, do we have to do that again? Sine final velocity?
Good. Do you want to do that?
Not personally.
Okay.
Does it have to do with the wording of the negative j hat? Or positive or negative j hat
What does the positive or negative mean?
direction?
Yeah. So most people in the final answer leave out direction.
But if you say negative, it's going towards the left.
Negative I hat is to the left, negative j hat's down.
So is his number correct, but then just different direction?
Oh, from what we have? That's not the issue. All right, velocity, is it a vector or a scalar?
Vector.
Yeah, that should have been an automatic response for everybody. How is a vector different from a scalar?
Has to do with magnitude and direction.
Okay, so whatever our answer is, it has to have a magnitude and direction. We have two choices, rectangular form or polar form. You want to do polar form? Okay. We will be using trig. I may as well keep that up, since we're about to use it. All right, so I'm adding two vectors here. How do you add vectors? How do you add them graphically?
The hypotenuse.
Okay, so how do you get to a hypotenuse? you're sort of sketching in the air.
I'm just thinking.
If I'm reading your mind correctly, I think you're on the right track. Oh, Robert?
Don't you draw the first one and then connect the tail of the next one to the head of the previous one and then continue?
So I'm gonna start, well, I start someplace when I'm drawing them. So I've got two vectors. One is 24 I hat, so that's to the right, 24. Now I'm here. I go down 35.9. And those do have units, meters per second, meters per second. Typically, I know my final answer will have meters per second in it, so I don't need to keep track of them as I go. All right, so I've got that plus that. Where is the resultant? How do I draw, because
The hypotenuse. Would be the hypotenuse
going which direction?
from this way.
Yeah. The hypotenuse or the resultant. It's a hypotenuse because these are perpendicular to each other, but the resultant is from where you start to where you end. There's my resultant. That is a right angle, conveniently.
You just add it here.
Yep. No, I guess I'm using R twice there. So the magnitude of my resultant vector, or which is, I guess, the magnitude of my velocity vector, which I guess is my final speed, is. I know it's bigger than 35.9 and less than 59.9.
$43.18
43.18.
meters per